Good day to all of you. Today we shall study graph data structure. Our sincere thanks and acknowledgement to authors Ellis Horowitz, Sarta Sani and Susan Anderson Freed, authors of the textbook with title Fundamentals of Data Structures in C. The content of discussion I have taken from this textbook. So first, what is graph? Graph is a non-linear data structure. It consists of vertices and edges. Vertices sometimes they are referred to as nodes and edges are referred to as lines or arcs that connect any two nodes of a graph. So graph is composed of set of vertices and set of edges. Hence it can be denoted as G. It is for graph and it is the collection of vertices and edges. V stands for vertices, E stands for edges. Now let us consider some sample graphs. So this is graph G1, this is graph G2, this is graph G3. So G1 and G2 are undirected graph because there is no arrow mark for any edge here. In this also there is no arrow mark for any edges here. But in G3, node 0 to 1, one arrow is there. 1 to 0, one directed edge is there. 1 to 2, one more directed edge is there. Because the edges are directed here, graph G3 is called as directed graph. So G1 is undirected, G2 is also undirected graph, but G3 is directed graph. So for this set of representations of these graphs in the form of here vertices and edges. So set of vertices for graph G1. So node this 0, 1, 2, 3 are called as nodes or vertices. So V of G1 is set of 0, 1, 2, 3. Similarly, V of G2 is 0, 1, 2, 3, 4, 5, 6. That is what is written here. Similarly, V of G3, set of vertices in graph 3, that is 0, 1, 2. 0, 1, 2. Now, edges in graph 1. So, set of edges in graph 1. So, in graph 1, so edge from 0 to 1, 0 to 1, 0 to 2, 0 to 2, 0 to 3, 0 to 3. Similarly, 1 to 2, 1 to 2, 1 to 3, 1 to 3, 2 to 3, 2 to 3. All the edges that come in this, they are written here as a set. So then set of edges in graph 2. So 0 to 1, 0 to 2, 1 to 3, 1 to 4, 2 to 5 and 2 to 6, they are written here. So then set of edges in graph G3. So because this is a directed graph, 0 to 1 only we'll have to write. Then 1 to 0 once again we'll have to write. 1 to 2 we have to write. There are 3 directed edges we have to list here. So these are some of the sample graphs as a set of vertices for each graph, set of edges for each graph, how they are written, that is given here. So graph G1, G2 are undirected, G3 is directed graph. Next we will see two graph representations. There are two types of representations, adjacency matrix and adjacency list. What is the meaning of these two we shall see next. First we will see to what is meant by adjacency matrix representation of a graph. Let us consider this example graph. So G is for graph, it is the set of vertices and edges. How many vertices are here? 1, 2, 3, 4, 5. 5 vertices are there. How many edges are there? 1, 2, 3, 4, 5, 6, 7 edges are there. Okay. Next, what is the meaning of adjacent node? For 0 node, 1 and 4 are adjacent node because they are connected through edges. 2 is not adjacent node to 0. 3 is not adjacent node to 0. That is the meaning of adjacent node. So in adjacency matrix, how many vertices they are listed as row wise and column wise. So 0, 1, 2, 3, 4, those vertices are listed here 0, 1, 2, 3, 4, row wise, column wise 0, 1, 2, 3, 4. After that, for 0 row, 0 column, so what is filled? 0 is filled, because for 0 to 0 there is no edge. Next, for 0, 1, so between 0, 1 there is one edge, means 1 is adjacent to 0, that is why 1 is written. Similarly, 0 and 4, so between 0 and 4 there is one edge, and 4 is the adjacent node, that is why for 0, and hence 1 is filled here. So for 0 vertex, only 1 and 4 are the adjacent node because they are connected through edges. Only there 1 is filled, otherwise 0 is filled. This procedure is followed for all the vertices. Now vertex 1 if you consider, so adjacent nodes 2, 3, 4, 0, because it is connected through edges to all other vertices except 1 to 1. That is why 1 to 1 only, that is 0, remaining are entered as 1. Similarly for 2 adjacent nodes are 1 and 3. For 2 adjacent nodes are 1 and 3, so only there 1 is filled. The remaining are 0. For 3, the adjacent nodes are 1, 2, 4 because they are connected through edges. So for 3, this 1, then 2, then 4. 1, 2, 4. Only there 1 is filled. Remaining zeros are filled. And lastly for vertex 4, it is connected to 3, 1, 0. So hence 3, 1, 0 are adjacent nodes for 4. So for 4, here 0, 1, 3. 0, 1, 3. There 1 is filled. Remaining place 0 is filled. Okay. Because 4 to 4 there is no connection, that is also filled here 0. This is how adjacency matrix for the given graph is written. This is adjacency matrix representation of this graph. Okay. Next we shall see what is meant by adjacency list representation of the graph. This is the given graph and this is the adjacency list representation for this graph. So this graph has 5 vertices 0, 1, 2, 3, 4 and 7 edges 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4 are the vertices. So in adjacency list representation, array of linked list is taken. Size of array is equal to number of vertices. So here this is array. So array size means one location 2, 3, 4, 5. So what is the size of this array? 5. It is equal to how many number of vertices are present in the graph. So in this array, this is the index. What is the index? So first position. So it is the location with index 0. So this is connected to node 1. Means 1 is the adjacent node for 0 and 4. How many nodes are there? 1, 2. So with index 0, in that what linked list we have taken, there will be 2 elements 1, 4 which correspond to 1, 4 which are the adjacent nodes for 0. Because this is the array of linked list, so linked list means this location with 0 index, there the address of this node is connected where data is 1. Then one more memory location is associated with this where the address of node with data 4 is stored, and it has one more memory location, so where null is stored because further there are no elements, further there are no adjacent nodes other than 1 and 4. Here for each node 2 locations are associated, one with data, another with pointer which stores the address of the another adjacent node. So this is having null because 1 is adjacent to 0, 4 is adjacent to 0. We may connect 0 to 1 here, 1 to 4, or 0 to 4, 4 to 1 in any order. Anyway, 1 and 4 are shown here only to, and hence the address or the pointer in the last one is stored with null. So this is with respect to vertex 0. Next, vertex 1, if you take vertex 1, 2 is adjacent to 1 because it is connected, 3 is adjacent to 1 because it is connected through an edge, 4 is adjacent to 1 because it is connected through an edge, 0 is also adjacent to 1 because it is connected to 1. So in this list, how many elements will be there? 4. So this array with index 1, because vertex 1 we are talking, so this is connected to 0, so 0, then 4 also, so 4, then it is connected to 2, then 3. Here whatever be the order of connection, so for this one 0, 4, 3, 2 must be listed in the set of linked list. So hence for vertex 1, so there must be 0, 4, 2, 3 vertex of this graph because all 4 are adjacent to 1. They may be connected in any order. The last one is made to store null as the pointer. So similarly, index 2 memory location in this array of third linked list, it is connected to 1 and then to 3. 3 is connected to null because only 2 are there. For this 2, 1 is adjacent, 3 is adjacent because they are connected through edges. Hence for 2, so in array with index 2 which corresponds to vertex 2, there the address of 1 is stored which is adjacent to 2, and 1 is made to point to 3 which is adjacent to 2. Both are over, hence 3 is made to point to null. That will be the end of linked list which corresponds to vertex 2. Similarly 3 here, it is connected to 2, 1, 4. So these are the 3 adjacent. So for array location with index 3, there this linked list is connected, means this memory is made to point to node 1. So this stores the address of node 4 and this stores the address of 2, and the last one is made to store null. This indicates null. And for the last vertex 4, so in array with index position 4, there that memory location is made to point to one of the adjacent node which is adjacent to 4 here, that is 3. Then one more should be considered 1 and then 0. So 3 is connected to 0, then its 0 pointer is connected to 1 and 1's pointer is the last one and that is made to store null. Okay. This is how for the given graph adjacency list is formed. So this is the adjacency list for given graph. Next we'll see to some example graphs. This is undirected graph. It has 3 vertices and 3 edges. So because 3 vertices row wise, 3 vertices are marked here 0, 1, 2, column wise 0, 1, 2, and for node 0, 1 and 2 are adjacent because they are connected to edges. So for node 0, 1, 2 are adjacent, there 1 is filled. So 0 to 0 there is no connection, that is why 0 to 0, 0 is filled. So for 1, 2 and 0 are incident or adjacent. So for 1, 0 and 2 they are filled with 1. 1 to 1 there is no connection. So 1 to 1 there is 0. Similarly for 2, 0 and 1 are adjacent nodes. For 2, 0 and 1 are adjacent, 1 is filled. So 2 to 2 there is no connection, hence 2 to 2, 0 is filled. So this is the adjacency matrix for given undirected graph. Next, considering directed graph, there are three vertices 0, 1, 2. Hence row wise 0, 1, 2, column wise 0, 1, 2. Three vertices or three numbers are taken here. Now because this is directed graph, we'll have to consider directed edges. So for vertex 0, okay. So 0 to 0 there is no edge. 0 to 1 there is no edge. 0 to 2 there is no edge. So 0 to 0, 0 to 1, 0 to 2 all are filled with 0. Next for vertex 1. 1 to 0 there is one directed line. For vertex 1, 1 to 0. So that is why it is filled with 1. 1 to 2 there is arrowed line. That is why for vertex 1 and 2 here 1 to 2 there is arrowed line. That is why 1 is filled. And this is filled 0 because 1 to 1 there is no arrowed line. Next for vertex 2, 2 to 2 there is no arrowed line. So 2 to 2 there is no arrowed line, 0 is filled. 1 there is no arrowed lines, 0 is filled. But 2 to 0 there is arrowed line. So 2 to 0, that is why 1 is filled. This is how adjacency matrix for the given directed graph it is written. Next for this directed graph, let us write adjacency list. There are 3 vertices, hence array size is 3 with index 0, 1, 2. So in this memory location, no nodes are connected, hence here null must be stored. Okay. Why? For vertex 0, from there no arrowed lines are connected to any of the nodes. Next, in this memory location which corresponds to vertex 1, there is arrowed line from 1 to 2, 1 to 0. That is why in this location node 0 address is stored. And with node 0, another memory location will be there. There node 2 address will be stored because from 1 to 2, one arrowed line is there. So from 1 to 0, 1 to 2, there are 2 elements being connected with arrowed lines. Hence in this linked list 2 elements 0 and 2. 2 elements are covered here 0 and 2, which are connected from 1 through arrowed line. And in this memory location which corresponds to vertex 2. So from vertex 2 there is one arrowed line, only one, that is to 0. That is why in this memory location address of node 0 is stored. So with this node 0 one more memory location will be there. Their null will be stored. Okay. This is how adjacency list is written for directed graph. Next we shall consider undirected graph. Here 3 vertices are there. So in the array here 3 locations will be there. Here the address of node 1 is stored because it is adjacent to 0. Then another memory location will be there with node 1. Their address of node 2 is stored because node 2 is also adjacent to 0. Here one more memory location will be there with 2. Their null is stored because only 2 elements, that is 1 and 2, are adjacent to 0. Hence here only 2 elements are included in this linked list which corresponds to vertex 0. For vertex 1, so 0 and 2 elements. So 1 is connected to 0, 0 is connected to 2. 2 elements are over and the last one is made to store null. For vertex 2, there are 2 elements 0 and 1. So for vertex 2, 2 is connected to 0, 0 is connected to 1 and the last one is made to store null. Here the point to be noted that this is one memory location. It stores the address of node 1. Then this is node 1 data. One more memory location will be there that will be storing the address. So here it is made to store the address of node 2, because 1 and 2 are adjacent to 0. So with vertex 0, so 1 and 2 are represented here and connected. So with 2, one more memory location is there. This being the last, here null is stored. So linked list means list of data nodes which are made to point to next node. Okay. By storing the address of next node in extra memory location with each. Okay. Next we shall solve one problem, and this is the problem taken from final exam. So for the graph shown here, show adjacency matrix and adjacency list representation. This is the graph what is shown here. So what we can see here, A, B, C, D, E, F. These are the vertices, and in between we have arrowed lines, so directed edges. So hence this is directed graph. And how to solve this we'll see next. That is how to write adjacency matrix and adjacency list for this given graph. Okay. So taking the given graph, here A, B, C, D, E, F are the vertices. So row wise A, B, C, D, E, F, column wise A, B, C, D, E, F are written first. Next, for vertex A, so A to B there is arrowed line, A to C there is arrowed line, A to D there is arrowed line. 3 arrowed lines, A to B, A to C, A to D. Only there 1 is filled, in remaining places 0 is filled. Similarly for vertex B, B to A connection is there, B to C connection is there, B to E connection is there. So B to A, B to C, B to E. Only there 1 is filled. So for C, C to D, C to F connection is there. Hence C to D, C to F. Only those places it is filled with, 1 remaining places 0. And for D, D to F is there, D to E is there. So D to E, D to F. Only there 1 is filled. Then remaining places 0. So E, if you take E to F, it is connected. So only E to F 1 is written. Remaining places 0. So F, if you take, it is not connected with arrowed line anywhere. From here there is no arrow to any other node. Hence all are 0 here. This is how adjacency matrix is written for the given graph. This is how adjacency matrix is written for the given graph. This is the adjacency matrix for the given graph that is obtained. Next, for the given graph, how to write adjacency list. So these vertices, how many vertices here? A, B, C, D, E, F. 6 vertices are there, and in this array, here 6 vertices A, B, C, D, E corresponding 6 locations are taken. In the first one, which corresponds to A, their address of node B is stored. Okay. Because A to B there is 1 arrowed line. So A to C is also there. Hence B node in another memory location related to that, in that address of node C is stored. Then A node is also connected to D node with arrowed line. Hence in C another memory location, their address of D is stored. So 3 elements are over. So the last one is stored with null. Next, this procedure is repeated for B node. So from B to C arrowed line, E to arrowed line, then A to arrowed line. So A, E, C. So B memory location, here address of A is stored. In another memory location of node A, address of C is stored. In another memory location of node C, address of node E is stored, and the last one is stored with null. Next, for C, there is arrowed line C to D, C to F. So this memory location which corresponds to vertex C, their address of node D is stored. So node D related another memory location, their address of node F is stored, and another memory location of F is stored with null, because only two elements are connected to C with directed lines. Next, taking D, D is connected with arrowed line to F, it is connected to E also. So from this memory location, so here which corresponds to D vertex, in this memory location address of node E, and this memory location which is associated with node E, there the address of node F. In this memory location which is associated with node F, null is stored. Then for node E, so from E to F only one connection is there. So in this memory location which corresponds to vertex E, their address of node F is stored. In this memory location which is there with node F, their null is stored. Then node F is not connected with arrowed line to any other node. So in this memory location in this array, null is stored. Okay. This is how adjacency list is written for given graph. That completes the solution. I hope you understood. Thank you.